Again, it's a rich thing.
What is going on, guys? Welcome back. In today's video, we're going to talk about how to properly split your training and testing data in machine learning. Now, I want to mention up front here that I'm a bit cold, so my voice is going to be a little bit different, and you can prepare for a couple of voice cracks, probably. And I also want to mention that what I'm going to show you today, I got from the book Hands-on Machine Learning with Scikit-learn, Keras, and TensorFlow. So I just wanted to give credit here. They're not sponsoring this video. It's just a book that I'm reading currently. And we're going to talk about train test split in a more advanced way. So usually what we do in tutorials and mini projects and examples is we use the basic train test split function of scikit-learn. So let me give you an example here. I'm going to import numpy as np, and I'm going to import pandas as pd. And then I'm going to load a data set that I have prepared here. So you can choose whatever data set you want. I have a data set with avocado prices. So pd.read CSV avocado.csv. So we can look at that data set. We can say data.head. And we can see that we have an unnamed column. We have a date column. We have a bunch of different features. And we have this average price here. So let's pretend for this video that our goal is to build a regression model that predicts the average price based on the other features. What we want to do here is we want to do a train test split. So we want to split the data set into training data and into testing data. We want to have a data set for training the model, and we want to have a data set for validating that the model can perform well on unseen data before we launch it into production. Now, for this, oftentimes we just use the train test split function. So we say from sklearn.model selection, we're going to import the train test split. And we say data, or actually we say train data, test data equals train test split. And we pass the data, and we pass a test size of usually 20%. So we can look at the train data now, and we will see that the split was successful. We have some part of the data in the training data. However, let me show you why this sometimes is not enough, because sometimes we want to have certain proportions in the training and testing data set that are the same. And for this, we're going to introduce a new column. We're going to say data price category, and for this we're going to say pd.cut. We're going to cut, basically this means that we're creating bins. We're binning the values into discrete intervals, and because we have a lot of different prices, but for example 1.33 cents and 1.35 cents is very similar. They're not that far apart. We can use that as one category, and because of that we're going to say data, and we're going to split, or we're going to bin the values of the average price. And the bins that we're going to choose for this, we're going to have to look at the range. So we're going to say data.describe. And we're going to see that the minimum value is 44 cents and the maximum value is 3.25 cents. So no, $3.25. And the mean is 140. So what we're going to do here is we're going to define the bins as from 0 to, let's say, 0.7 to, let's say, 1.2 to 1.6 to 2.5 to 3, and then to np.infinity. So those are the ranges. Those are the intervals. We say this here from 0 cents to 0.7, which is 70 cents. We're going to say this is very cheap. Then from this price to this price, it's still cheap. This is the average category. This is a little bit more expensive. This is even more expensive, and this is very expensive up until infinity. Those are the intervals. And we're not going to use this feature for anything except for just looking at the proportions. So we don't need meaningful labels. We're just going to call the labels 1, 2, 3, 4, 5, 6. Let's do that, and now let's rerun this. So let's copy this and run this here again. And now let's look at the value counts. We're going to say train data. We're going to look at the average price, or actually we're going to look at the price category. Value counts. And now we're going to do the same thing for the testing data. And as you can see, we have these absolute numbers. Now let's go ahead and divide by the length of the training data. And let's do that here as well. I'm going to just divide. Come on. I'm going to divide by the length of the test data. And you can see we have similar proportions, but not exactly the same proportions. So you can see here we have 0.35, here we have 0.36. And for a lot of use cases, this is enough, but oftentimes we want to have a very accurate representation. So we want to have representative training and testing data and not just similar. We want to have exact, like at least 2 decimal places, but preferably 3 or 4 accuracy. And because of that, we're going to talk about another method for train test splitting, and this is the shuffle or the stratified shuffle split. And for this, we're going to say from sklearn.model selection, we're going to import the stratified shuffle split. And this is a class now. This is not a function, so we need to create an object. We're going to say split equals stratified. And by the way, one thing that I want to mention, I forgot about that, is that since this split is completely random, even though most of the time it's going to be kind of representative, sometimes in extreme cases, it can also be extremely skewed. So it doesn't have to be, but oftentimes it can be completely different since it's completely random. The likelihood is very, very small, but it can happen. With a stratified shuffle split, it cannot happen. So here we're going to say stratified shuffle split. We're going to pass n splits equals 1 because we only want to have 1 split. And then we're going to say test size equals 0.2. And now we need to iterate over that because that is going to return a generator. And for this, we're going to say for train IDs for train indices and test IDs for test indices. In split.split, we're going to split on the data, and we're going to consider the column price category. And let me just look at the code here so I don't mess up anything. Where is it? There you go. Yeah, that's basically it. So for that, this returns a generator, and we iterate over that generator. We only have 1 item, so that's just because we need to do it. And here we have the indices. So in order to get the train data, we just say equals data.location, and we pass the train IDs. And then test data is going to be data.location test IDs. And that should work. And now we can do the same thing. We can go ahead and copy this line. We can paste it here. We can run it, and we can copy this line. We can paste it here, and we can run it. And you can see that now we have a very, very accurate representative split. So we have very similar proportions. We have 0.3539. Here we have the same 3389, the same 2809, 2810. Now, the lower you go, obviously, the harder it's going to be very accurate because, of course, you have fewer and fewer values. But as you can see, this is a very good split, a very accurate split, and it represents at least the prices properly in the training and in the testing data set. So that's it for today's video. I hope you enjoyed and I hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you very much for watching. See you in the next video, and bye.